Okay, hi everyone. This is CHEN 121, week 7, and this week we'll continue talking about plotting in Python. We're having a look at a second set of experimental data, um, which is typical to what you would mostly use Python as an engineer, just looking at data collected experimentally or generated using an equation and trying to plot them. And over the next few weeks, we'll have a look at how to generate trends, look at trends, maybe fit them using equations, etc. But for this week, we'll be looking at plotting in Python. Again, just practicing, doing a bit more practice on how to make these plots in Python. So let's have a look here. So you're given a following set of experimental data, which was measured in the lab. And again, using Python, right? Here we go. You have salt, two salts, NaCl and KCl. You have temperatures, so these experiments were ran over a bunch of temperatures, and they measured a bunch of things: refractive index, frequency and velocity at 90 degrees, frequency and velocity at 139.9 degrees. All right, so I have just a bunch of numbers here. And let's see what we want to do. Using Python, write a script to generate the following plots. Number 1, compare the effective temperature on refractive index for both NaCl and KCl, A on the same plot, B on a side-by-side plot. Okay, sounds good. So let's move on to Spider and let's start working on these exercises. So let me share my screen for Spider here and we can get started. Okay, so similar to last week when we want to plot and we want to do some numerical manipulations on arrays or even on numbers, we need to import a bunch of libraries. And last week we said we're going to import, first of all, we'll import three things. First of all, import numpy as np, import pandas as pd, and then the third one is import matplotlib.py plot as plt. And the three libraries, again, they are similar to what we did last week. First one is the NumPy library, which is the numerical Python. Again, used to do some manipulations in Python, whether you want to multiplication, addition, multiply over an array, do some for loop manipulations, whatever. Pandas, again, is used primarily for data analysis and when dealing with arrays, dealing with lists. Maybe we haven't used them much over the past couple of weeks, but it's good practice to import them so that when we need it, it's there. And then matplotlib.pyplot as plt. This is really the primary graphical library which we rely on to generate our plots, generate our figures. Okay, so we have a bunch of experimental data. So our first step will be to import all of this experimental data. So I've already prepared the arrays and I'm just going to copy paste them here. And let's have a look at these arrays and compare them to the experimental data we have, right? So we have temperature of NaCl. So this is the data set for NaCl. Let me just add a comment. And here is the data set for KCl. And again, I have the temperature, the refractive index, frequency at 90, velocity at 90, frequency at 139, velocity at 139. Similarly for KCl, I have my temperature, I have my refractive index. Let me zoom in a bit. Right. Temperature, refractive index, frequency at 90, velocity at 90, frequency at 139, and velocity at 139. So, and this is just the experimental data which we had given in the prompt. So if I go back to the prompt here, so I have my temperature, refractive index, frequency at 90, velocity at 90, frequency at 139, velocity at 139 for NaCl, and then again for KCl. Just usually when entering this type of data, just be careful. You don't skip a line, you don't, skip a number. Otherwise your plots are gonna look a bit clunky. Okay, so let's look at the first prompt here. Compare the effective temperature on refractive index for both NaCl and KCl. First of all, on the same plot, and then second of all, on a side-by-side plot. So I want to plot temperature versus refractive index for NaCl and temperature versus refractive index for KCl on the same plot initially, and then on a side-by-side plot. So let's do it. So if we recall, how do you generate a figure, right? So this is one, and let's say A, this is on the same plot, just a comment here. So one thing which we're gonna start doing this week, which we didn't do last week, is before plotting, I'm gonna add a line called plot plt.figure brackets. And what this does, it basically just generates a new figure. Okay, and this is important because when you want to generate a bunch of figures after each other in the same script, you want to separate them as different entities. And what this does is basically tells Python, let's start a new figure, which we're going to do this. And then before the next figure, you write the same line, plt.figure, so that you start a new figure and you start doing your manipulations. Okay, so let's plot plt. So we're going to plot the first line, plt.plot. Again, plt is you're calling the matplotlib library. Plt, you're giving it the command plot, or you're calling the function plot. And we're going to put our x-axis first. We're going to do it first for NaCl. And then we want to plot the refractive index for NaCl. Oops, r underscore NaCl. And this is the x, this is the y. And then afterwards, we have some space where we can add some different arguments. First argument is usually the color. So we could add blue. I'm going to add O and dashes. So what this is going to do, blue will be the color of the line. O will be basically the shape of the points, and the dash will be the connection between the points. So I should have a blue line with circles for where the data points are. Good. And then I'm going to add another command, which is the label command, right? And again, when you're adding two figures on the same plot, it's always a good idea to label them, right? So that when you have a legend, you can easily see, okay, this line is for NaCl, this line is for KCl, and this makes a lot more sense. Okay, so usually you add label for multiple plots on the same figure. Okay, so this is our first line. Second line, same idea, plt.plot t, and then now I'm plotting KCl, right? KCl or KCl, and let's choose a different combination. I want a red line with x's for the points and connecting them using lines, and I'm going to add the label equals KCl. Okay, so this should really generate our basic figure which we're looking for. So let's run it and have a look. It's going to run. You see we have a basic figure. You know, usually as an engineer, you don't want a figure like this because you don't have any information on the x-axis, on the y-axis. It's really not showing you anything. So we need to add our x label, our y label, maybe a title for the figure, and maybe a legend. So let's start adding these ancillaries, right? So if you recall, let's add a y label plt to add a y label, plt.ylabel. And in this case, the y label will be the refractive index, right? Similarly, plt.xlabel, and in this case, the x label is temperature in Celsius. Now let's run this guy. Okay, so I have my refractive index, I have my temperature in Celsius. Let's add a title for this plot, right? Oops. So to add a title, I'm gonna have plt.title, and let's call this temperature versus refractive index for NaCl and KCl. This should add a title, and then let's add a legend, plt.legend. And again, when calling the legend function, you have only one parameter to input, and it's the location, usually LOC equals, I like to use best. You can also add like upper left, upper right, bottom left, bottom right, or center to put it in any location. But if you choose best, the program will put it in the best location where space is available. So again, plt plot, you draw your line, and then plt.ylabel, plt.xlabel, plt.title, plt.legend. You need them to add the rest of the cosmetic things which are important for your figure so that you can present it in a way which the reader can understand. And again, plt.legend, the argument location best. I think you can put upper right. Let's try this. I guess upper right is the same. Let's try upper left. No, upper left. Let's see if it moves. Here we go. It's moving around. Center. We'll put it in the middle. You can put lower left, lower right, lower center, any location you want. Usually I choose just best and let the program decide. But sometimes, you want to have full control over these cosmetics. Good. Okay, let's move on to the next problem. So this is on the same plot. Now we want to do the same thing. Side-by-side plots. Okay, so when generating side-by-side plots, if you recall last week, it's basically the same formula. So first of all, I call figure. I give the figure a name, AXS. Let's just call it AXS, similar to last week. And then I need to call a function plt.subplots. And this function will take two arguments, basically the x and the y, or how you want this grid of plots to look like. So fig, this is part of the command. AXS is the name of this figure. plt.subplots 1, 2 is you want your figure to have one row and two columns, right? So I'm going to put them side by side. And I'm not including this plt.figure because this first line serves the same purpose. So once you have this first line when generating subplots, it automatically tells Python, let's generate a new figure. So you don't want to add, I mean, you can add it, it's going to be redundant. So this line also serves this purpose. Good. So now I told Python, get ready. I want a grid of a figure having two subplots next to each other, one row, two columns. And now I'm going to start dropping elements into these subplots. And to drop elements, you just call the figure name. In this case, it's AXS, and then you put the index. If you recall last week, because it was a 2x2 figure, we had 0, 0, right? And then 0, 1, all the way to 1, 1, right? And this is valid if your dimensions are 2x2 or larger. However, if your dimensions are just one row and two columns, you just need to use one argument here, right? 0, 1, or 0, and then we're going to have AXS1. And the reason is I'm only putting one argument because, intuitively, if you just tell it 0, Python will understand. This is the first location, 1, is the second location. You don't really need to put the two um, indices, okay? And if you put the two indices, you're gonna get an error. So just be careful with this when generating a 1-row, 2-column plot or a 1-column, 2-row plot. The same idea applies. So when doing this, let's do this. So we want axs of 0 plot. And in this case, we want to plot, let's copy the same thing here, right? We're just putting the same plot side by side. And when generating subplots now, we also want to add the X label, the Y label, and a title, right? So let's first of all add the X label and Y label. And to do that, I use the argument set. X label will be temperature in Celsius, right? And Y label, in this case, Y label will be refractive index, right? Again, same idea. However, when doing subplots, instead of doing them separately, I'm just using set X label equals, and then Y label equals. I also want to draw a title or add a title to this figure. And when adding a title in a subplot, to use a different sort of format. Again, it's set title. And in this case, I'm going to add a title for this subplot. I'll just add NaCl. And this should be sufficient really to generate the first subplot. So if we run it, hopefully we can see half a figure in this case. Here we go. So we just have a half a figure here. We're not seeing the X label and the Y label. Let's verify what's going on here. So set X label, so we have a spelling error here. And Y label should be fine. So let's try it again. See if we see the X and Y labels in this case. Good. So now I see the X label, the Y label, and NaCl. One thing with subplots, which I like to add, is axs 0. I like to add a grid. So dot grid, and what this does is just add some lines. And usually grid takes an argument of true. You can add grid false if you want to switch it off. And which, the second argument in grid, switch. And I'm going to add both. So what this does is going to add both the major and the minor grid lines. And if I run it, I'll be able to see the grid with major lines and minor lines as well. You see, just makes it a bit easier to take a look, see where the points are on this figure when reading, especially when they're side by side. There are other manipulations, so you can add, if you want to control the range of this y-axis, the range of this x-axis, there's a lot of manipulation. I encourage you to go look online and find them and try to, find a way on how to troubleshoot your figures yourselves. Okay, so let's do the same thing for the second subplot. So for the second subplot here, instead of free typing the lines, I'm just going to copy them. I'm going to change the location to 1, right? And I'm going to change these guys. So now I'm not plotting TCL and KCL. I'm not plotting NaCl. I'm plotting the same information for KCl. And then let's keep it consistent. So instead of B, we're just going R, X, and the label, I'm just going to call it KCl. So for the second subplot here, instead of retyping everything, I just copied the same list of commands, pasted them, and just changed the location. First of all, I want it to be in this location, so it's axs sub 1. And I'm just calling a different couple of lists to plot, right? So now my x-axis and the y-axis for axs1 will be for KCl, so it will be T underscore KCL and R underscore KCL. Set the x-axis and the y-axis. The x label is the same temperature in Celsius. The y-axis is the same, which is the refractive index. What else? Set title. So for the title, I want KCL, not NaCl. And then grid true, which both. So again, I also want to see a grid on this side. So let's run it and see if this will give us the figure which we're interested in. Okay, so it's plotting the figure. It's just that, you know, they tend to run over each other and it just looks a bit ugly. So for this case, with subplots, almost always we need to add this last line here, which is figure dot tight layout. And almost always when generating subfigures, you want to add this line to sort of, you know, clean up the way it looks, right? Because at the moment it looks a bit clunky and they're all over each other. But now, once I add this line, it cleans up nicely and you can see they're separate entities and everything looks much better. Okay, so now we finished A. We generated figures on the same plot. We generated figures on a side-by-side plot. Let's move on to number 2 in this lab. All right. Let's have a look here. I am looking at number 2. So for number 2 here, I need to generate a 2x2 figure showing the frequency and velocity of NaCl at both angles as functions of temperature. So basically I want to plot temperature versus frequency, temperature versus velocity at 90, and then temperature versus frequency and temperature versus velocity at 139, having just a 2x2. So maybe I'll put these two on a row and then these two on the row after it, generate 4 figures in a 2x2 configuration. And this is very similar to what we did last week. We're just trying to remember the type of things which we have to do for this type of activity. Let's go to our Python script and let me copy this, copy the instruction just so that we remember what we want to do. Move them on separate lines just so that you can see what we're trying to do, what we're aiming for. Good. Let's start. So again, very similar to the previous subplot type of idea, the list of commands will be very similar. Let's start fig, AXS, and now I'm going to call it AXS1, just give it a different name so that in case you want to troubleshoot, always good practice, in case you want to troubleshoot, go back, have a look. They're separate entities and you can easily do that. plt.subplots, and now I want them 2 by 2, right? I want 2 rows and 2 columns. Good, and now let's start working on each one of these. And each one of these figures will have the same structure. I'll start with a plot. I will set the X label, the Y label. I will set the title, and then I will tell it to please add a grid. So let's start with the first one. I want AXS1 of 0, 0. Now it's 2 by 2, so I need to specify both, right? 0, 0 and 0, 1. 1, 0 and 1, 1, right? Adding just one command is not sufficient. Whereas for a 2 by 1 here, you just need to tell it, hey, this is 0, this is 1, and generate the plot. Good. So AXS00.plt. And now I want to plot temperature versus frequency, temperature versus velocity for both angles. So let's start with the 90 angle. So I'm plotting T-NaCl versus F90 NaCl. And then I will plot T-NaCl versus V90 NaCl, and T-F139, T-V139, right? So I want to plot T-NaCl, comma, F90, underscore NaCl. Let's try to stay with the same colors, blue, and let's give it blue O and connecting lines. All right, I'm not gonna add a label. You can always add a label if you want to, but I don't think we need to add a label. We'll just set the title for each figure, and this will serve as basically we're just labeling each figure. Usually adding a label is more useful when you have multiple lines on the same figure, But if you have distinct plots, you can use the title to do that purpose. Okay, AX1, 0, 0. Again, I'm going to set my X label in this case. It will be temperature in Celsius, right? And the Y label will be frequency in gigahertz, right? So Y label is frequency in gigahertz. Okay, and then let's continue AXS 0, 0. So after the plot, after the set label, we want to set the title. Set title. In this case, we're plotting the temperature, or we're plotting the frequency at 90 degrees, right? So let's just call it frequency at 90 degrees, right? I'm plotting temperature versus frequency. And AXS1, 0, 0, I always like to add this grid true, and which is both. Okay, let's run this command. Hopefully we get just 4 figures with the top left figure shown. Let's make sure everything looks fine. Okay, okay, okay. So I have my frequency at 90 degrees for NaCl. Looks okay. Now let's generate the rest of these guys. AXS1, and feel free really to do any sort of artistic, cosmetic thing you think or you want to do. It's not really a big deal. Use this opportunity to learn how to do these things. Okay, so now I'm gonna plot V90 NaCl, and for the velocity, I'm gonna use red X, red line with X's to show the point. AXS1, again, 0, 1. Again, I'm just gonna add the title, so set. The X label in this case, similarly, will be temperature in Celsius. And the Y label will be velocity in meter per second. And be careful with these apostrophes, just if you forget one apostrophe, forget one bracket, it's Python tends to, you're gonna get an error, you won't be able to plot it, okay? So we set the label. Next thing is we're gonna set the title, set title, and in this case, it will be velocity at 90 degrees. And finally, AXS1 of 0, 1 dot grid. Just adding this grid. Feel free to add it or not, it's up to you. Or maybe if you want to add only one set of lines. Again, feel free to do any of these cosmetic things. And if I run it, hopefully we'll see a second figure here with the velocity, which is red. Okay, previous 2 figures have been showing up. There we go. So I have my velocity at 90 degrees. All right, let's add the bottom 2 figures. So I have AXS1. So I have 0, 0, 0, 1. Now I have 1, 0. In this case, I'm plotting T NaCl, and I'm plotting now, what did we call it? F139. So I'm plotting F139 underscore NaCl, and let's use blue. This time let's keep it as an X. Okay. So I have a blue X. Actually, let's do something. Let's change this velocity to R on a circle. So I'll have these top 2 as circles and then the bottom 2 as X's. Okay. And then AXS1 comma 0 dot set x label again will be temperature in Celsius, and y label will be frequency in gigahertz. Good, and then AX S1 10 set title. In this case, it will be frequency at 139.9 degrees. And just for accuracy, I'm going to call this at 90.1 and 90.1, just to match the experimental data sets. Good. So I have my, we put our plot. No, so this is going to give us an error. Again, for subplots, I'm using the plot command as a whole, similar to the other ones, just be careful. AXS plot set, we set the X label, we set the Y label, we set the title, and let's add this grid line as well. 10.grid true, and which equals good. Now let's run it. Hopefully we'll see the third figure here. And then we're going to add the final figure for part 2. Good, and they're all over each other at the moment, but we're going to add this line tight layout and it will clean up. Let's add it now actually, so that we can have a clean figure, and then we could add the last one in a bit. There you go. See, the figures are all separate. Looks good. Let's add the last one. So the last one will be AXS. Oops. AXS 1 off 1,1 plot, and now I have frequency at 90, frequency at 139, velocity at 90. I'm missing velocity at 139, so it will be again T, NaCl, velocity 139, NaCl, and set this is blue circles, blue crosses, red circles. We're going to make this red crosses, right? Red X dash. Good. AXS1 1,1 dot set X label will be temperature in Celsius. Y label will be velocity in meter per second. Okay, so I put my x-axis, my y-axis. Now I'm going to put a title, AXS1 1,1, and set title, and this will be velocity at 139.9 degrees. And let's add our last line, which we usually add just for the grid, AXS1 1,1 dot grid, and I want this to be true, and which I want both lines to be added. Good. Now let's run it. Okay, so we have an error here. Trues. Okay, I have a misspelled here. It has to be true. Let's run it. Now we should be able to see our figures. All the figures which we're looking for parts 1 and 2 of this lab. Good. So you see the frequency, velocity looks good. And the figure before it, side by side, same plot, can generate a bunch of different plots. And again, if you want to change the colors, want to change layout, do whatever you want to do. Cosmetically, feel free. You want to change the axis. If you look online, there's infinite information on Python. Take your freedoms in doing these things. Okay. Now let's go to number 3. Number 3 saying write a for loop that divides the velocity by the frequency for both angles and save the results in 2 new arrays. Plot the arrays as a function of temperature on the same figure. Okay. So I want to write a loop, a for loop that divides the velocity by the frequency for NaCl at both angles. So I want to get a ratio of velocity over frequency at 90 and a ratio of velocity over frequency at 139.9. And then I'm going to plot these two ratios as a function of temperature on the same figure. Okay, so let's work on this in Python. So let's go to Python here. Let's add our little comment. For both angles, and then plot function of temperature. Okay, so this is part 3. Okay, let's see how can we do this. So I'm going to need to generate a for loop, and then I'm going to need to save the results in 2 new arrays. So let's initialize the 2 new arrays. Okay, so let's initialize these 2 arrays. Again, before running a loop, you need to initialize the arrays you're using. And in this case, I'm going to go ratio, let's call it 90 NaCl, and ratio 139 NaCl. So I created 2 arrays. One array, I'm going to store these ratios at 90 degrees. And the other array, I'm going to store the ratios at 139. And I have my 2 arrays here. Okay. Now let's run a loop. So we want to run a loop over, or the length of this temperature. And then every time I'm going to divide velocity by frequency and then save this entry in my new array, and also divide velocity by frequency at 139 and save this in my new array. Okay, so let's see what the best way to do this is. So I go for I in T NaCl, which is our classical approach. This might not work out because for every run, I will take the value of temperature in NaCl, right? So in this case, I will be 800, 814, 829, and this is not very useful because I want I to be 1, 2, 3, 4, 5. Okay, and this is a common problem. So in order to basically loop over array indices, so in order to do this, I'm gonna do one thing. I'm gonna call len of T NaCl. And what this does, when I call the function len or length, it basically, so if I run it here, the bottom right, if you have a look, if I call length of T NaCl, just returns the length of this array. And I'm gonna add the function range, and we covered this function range maybe 2-3 weeks ago. Go back and revise, or go back and have a look at what we did back then. Basically, range is gonna run this loop over the range from 0 to 9, right? So if I call this function range of length of T NaCl, you're gonna see that it's gonna return 0, 9. So I'm gonna run this for loop from 0 to 9, basically. Okay, so what do I want to happen in every loop? We can do 2 things, right? We can first of all call ratio 90 underscore NaCl dot append, and I'm gonna append it with, what did we want to plot? It was velocity over frequency, right? So I want V 90 NaCl of I divided by F 90 NaCl of I. And what this does is, with every run, I'm adding a value, which is this ratio, to this list, right? And same thing I'm doing for the other one. Ratio 139 underscore NaCl dot append. And in this case, V 139 underscore NaCl I divided by F139 underscore NaCl I. So what I'm doing here is I'm running this loop. So the loop is going to start at 0. Then loop is going to start at 0. And when I is 0, I'm dividing the first value of this array by the first value of this array and adding it to this list. Similarly, the first value of this array by the first value of this array and adding it to this list, and going until I'm done with the list. Okay, so I created the two arrays. Now let's plot them. And to plot them, I'm gonna follow the same idea as we did here. plt.figure, right? plt. And I'm doing this to just create a new figure. If you don't add this line, it's gonna add the new figure in the 4th location here, right? Because this is the last active called figure in this script. So it's always good to do this so that now you're creating a new figure, starting off new, so that you don't, add figures on top of each other and confuse things. Okay, so now let's plt.plot, and I want to plot E NaCl, comma, ratio 90 underscore NaCl. So I'm plotting temperature versus the ratio. Again, let's add some labels, or let's add some colors. Let's use green. Oh, this time let's just use green. And let's add a label. Label will be V over F at 90.1 degrees, right? Then the next line, plt.plot T underscore NaCl, and ratio 139 underscore NaCl. And now I'm gonna add Y star this. That's the different type of the look, and then the label will be V over F at 139.9 degrees. Okay, let's run this figure before adding any more ancillaries, see what it's going to look like, and if we have any errors in this loop, which we can troubleshoot at this point. First figure, second figure, third figure, and fourth figure. Okay, this is our fourth figure, and these colors are a bit ugly. So I'll just go back to blue and red. It's up to you, whichever colors you want to use on your figures, right? Okay. Anyways, so I added my two plots. Let's add my X label, my Y label, the title, and let's add a legend as well. So I'm gonna have plt.x label, and the X label will be temperature in Celsius, plt.y label, and plt.y label will be let's call it velocity over frequency ratio for NaCl, and the units for this will be what was it? It was gigahertz meter per second, right? This is the unit for this guy. And let's add a title, plt.title, and let's call our title so what is this showing really? Sweet, it's effect of angle on velocity divided by frequency for NaCl. Okay, thank you. So this is the title of this figure, and let's add the grid. plt.grid true, and which, let's add both. What else are we adding? Let's add a legend. Let's add a legend here. plt.legend, plt.legend, and location. Again, I'm gonna just tell it to choose the best location. What else can we add? I think that's it. Let's run it and generate this figure. First figure looks okay. Okay. And this is our last figure. We have effect of angle on velocity frequency, velocity to frequency ratio, temperature in Celsius. This is our legend. These are two lines. Everything looks fine. So that's it. I guess we've completed the 3 exercises for this lab. Again, take your time, try them. I'm gonna post the script also in your prompt. However, try not to copy. Try to use it as a learning really experience, and take your time doing these exercises. Everything is due before next class. If you need some more time, send me an email. We can always extend it. But really just use this as an opportunity to try and learn this language. Okay, good. So we finished 1, 2, 3. And for your homework, I want you to generate a 2x2 plot for frequency and velocity of KCL. So it's very similar to this one, however, we're doing it for KCL. And then also do number 3 for KCL as well. And let me change this thing. Plot the arrays as a function of temperature. Let's do on A, the same figure. And basically let's do the same thing for this exercise here. Let you guys practice all of it, okay? On the same plot and side-by-side plot. And again, feel free to be creative, do whatever you want. Office hours will be from 5 to 7 every day of the week. One comment about office hours: when you join the Zoom link, just please wait a couple of minutes, because once you join, I get a notification and then I need to join Zoom, and this might take a few minutes. Just be a bit patient once you join, and I'll be there to answer your questions. Otherwise, you can always send me an email and I can reply back as soon as possible. All right, thank you very much. I'll talk to you guys next week. Take care.